Okay, so today we do the 2D momentum case, which is obviously the more complex one of the two. So here is how the problems usually are going to be presented. So a hockey puck of mass 0.16 kilograms, or basically 160 grams, sliding on a nearly frictionless surface. So that means the whole time it's moving, absolutely no change to its speed until the collision happens. With a velocity of 2 meters per second heading east, strikes a second puck, which is already what? At rest. So at the initial stage of the collision, right before, only one thing is moving. So it strikes the second puck, which is at rest, which has a mass of 0.17. So it's slightly heavier. It's only 10 grams heavier, 160 grams, 170 grams. After the collision immediately, the first puck, the one that was already in motion, deflects and has a velocity of 1.5 meters per second, which makes perfect sense. How much speed did it go in with? 2. How much speed did it leave the system with? Makes perfect sense because energy could never be gained. Energy could only be what? Be lost, because now the energy is between how many pucks now? 2. Some of the energy of the first puck was now transferred to the what? To the second puck. That's why there's no way it can speed up. If it speeds up, it means it has on its own, by itself, more energy than the system started with, which makes absolutely no sense. So it slowed down, but also what? Deflected up, north 31 east. The question is always the same. Determine the velocity the velocity of the second puck when? After the collision. Okay? All right. So, everyone, here's how we do all of these problems, whether in grade 12 or in first year physics. Okay? All right. So, what do you have here? In your slides, you have the second slide coming up. So, for the what? For the before picture. Okay. So, here's the before picture. Before, by the way, technically, if they actually are lined up like that, would this ever be a two-dimensional collision? Okay, raise your hand if you understand my question. My question was, if they're perfectly lined up like this, would this ever result in a two-dimensional collision? How many people say no? Okay, Noura, why not? Why would this, the way I sketched it, why would this never be a 2D? Exactly. If you really see it, they're actually perfectly what? Lined up, center to mass to center to mass, which means the only way this system could ever develop a collision is that this starts as 1D and also remains as what? 1D, right? The only two possibilities here is either maybe this one bounces and this one goes this way, or both of them go exactly straight into the east direction. However, one of them has to be what? They have to be what to make this a 2D after the collision? The center of mass has to be lined up or offset? Offset. Obviously, when I give you a 2D problem, you do not have to bother so much when you sketch it to make them what? Offset. We understand their offset, okay? But if you really want to sketch it properly, one of them should be at a lower level than the other. Regardless, we know what's going to happen. Just wanted to make sure that you know that. Okay. Um, so, which direction should be set to positive? East or west, like right or left? Right, because everything develops motion already going this way, so this should be positive, this should be negative. All right? Okay, perfect. Let me just follow with you. Okay, so far so good. Nothing that you have to write. Okay, let's do now the what? The initial x momentum. The initial momentum on the x. Okay, well, first of all, does the system have anything on the y to begin with? So everything on the y now is a 0. However, on the x, depends. Are you talking about the first ball or the second one? The second one has how much momentum right now? 0, because it's neither moving up or, sorry, like vertically or horizontally. This one has some momentum because it's got some mass and it's got some speed. Okay, so go ahead. That's the first step. Okay, so so again, see how many labels I'm using? I'm using 3 labels. I am using 1 to indicate I'm talking about object 1. I'm using I to indicate I'm talking about before the collision, like the initial stage, before hitting, before touching. And I'm using X because I know this is going to develop into a 2D problem. Okay, so Pix equals 0.16 times positive 2. Again, why is it positive? Because this is a velocity technically, and velocity needs a sign, so it's a positive. Okay, 0.32. How about P2Ix? P of ball 2 initially on the x would be just what? Would be 0. You can just write 0. Again, I'm a big fan of shortcuts as long as you know why they happen. Okay? So P2 initially on the x. All right. That takes care of the what? Of the initial x momentum. All right. Now we go into the initial y momentum. Both objects on the y initially had how much momentum? Well, one of them was not moving at all, so this has 0 momentum every dimension. This one was moving only this way. It had no vertical motion, which means its initial y momentum would be 0. So go ahead. P1iy is 0, and P2iy is 0. By the way, this is my subscript labeling. If you want to do fewer labels, it's completely up to you, as long as you know what each variable stands for. I'm just being very detailed and meticulous here. That's all. Okay, I already got the initial x momentum of the 2. I already got the initial y momentum of the 2. What should I do now? Nothing. I should add the x momenta, and I should add the y momenta as well. All right, here we go. If you add these two, because you can never mix dimensions, everyone. You can never mix dimensions. So now you have to add the what? You have to add the x's together, which is really easy. And you have to add the y's together, which is even easier. So that takes care of what? Of the first slide. Okay. My next slide is going to be more complex. Why? Because it will be the one with the deflection. It will be the one with the deflection. Okay. So let's go to the second slide, which you already have as well. Okay. Okay. We did say that the first ball, the one that was already in motion, deflected in which direction? Was it east, north, or northeast? According to the question. Northeast, which makes sense. Yep. North, 31 degrees east. Makes sense. Okay. So basically, just like, for example, when playing pool, you hit one, so they're offset, and this one. So I'm actually going to use, hold on. Got the tennis balls right here. Thank you. So, everyone. So right here, if they were perfectly lined up, and they hit, they still have to stay in which dimension? The same dimension, right? However, apparently, for example, this one was, look, my right hand, I'm gonna lift it up a little bit. So this one deflected this way. How would this one deflect? Down. So that's the question. So the question is always gonna be, how much angle did it deflect by, and at what speed immediately after the hit? Okay. Again, with the same what? With the same breakdown. So final x momentum. All right. Oh, okay. Final x momentum. Everyone, pencils down. Let's just work them mentally between each other, and then we'll write it down. Question. We're doing the x. This one to the 31. Is it opposite or adjacent? Just this part. Is this opposite or adjacent to the 31? It's opposite, because technically it's all the way up here as well. So this part is opposite to 31. What does that mean? If it's opposite, what is it? Cosine or sine? If it's opposite, it's sine. So this amount right here is the momentum, is the mass and speed of this one times the what? Times the cosine. So there we go. Go ahead. P, the momentum of the first ball in the final picture on the x-axis is 16 mass times speed times which component of the angle do you need? You need the sine, because it's what? It's this one or this one. Which is that? So can someone tell me what the expression would be for the P2Fx? What would be the x component of the momentum of this ball now? Anyone? By the way, I'll give you a hint. Look at the three things I used. What does the 0.16 represent? Mass. What does the 1.5 represent? the speed after the collision, and then whatever component in trigonometry that you need. So how would you change those three things to reflect the one for the second ball? Do you know the mass of the second ball? How much? 0.17. So we got that done. Do you know the speed of the second ball after the collision? No, you don't. So what do you just call it, for example? V2F, if you like. Okay? Now the question is, we want this one, everyone, right? We want this part. Is this sine or cosine of theta? This. How many people say it's cosine? It is cosine because remember, whenever you use the horizontal angle, whatever is on this axis is a cosine, and whatever is on this axis is what? If you use the other angle, what happens? They what? They switch. That's why this one technically it's not cosine of 31, it's sine of 31. All right, so again, the momentum of the second ball in the final picture on the x is mass times speed times cosine of theta. And you can do much with that because, by the way, how many unknowns do we have here? How many unknowns do I have in the second line? 2. I don't know the V2F, and I don't know the cosine theta. No problem. That's fine. Okay, what do you think my next step would be? It's already on your slide. The final y component. Who would like to work them out using those two lines as a guide? I'll give you a hint. You don't have to change much. You just have to change FU, but very critical elements there. Ammar, go. Thank you. This one becomes what? This one becomes cosine of 31. And this one becomes what? Sine of 31. There's also one more change that you need to do. Aside from the change of those being y and y. There's also one other change. Noura, go ahead. Yes. The y momentum of this ball is pointing which way? Up, which is what? But the y momentum of this ball is pointing which way? Down. So instead of plus here for the second ball, you're going to have what? You're going to have what? Because remember, those those fundamentally are vectors all the time. So to Ammar's and Noura's point, this is exactly what we need. See, barely anything has changed, but it's a very critical change. Momentum of the first ball on the y is still positive because it's pointing up, and I designated positive to be up. 16, 1.5, cosine of 31. Momentum of the second ball on the y is 17 V2F sine, but with a negative. What's my second step after that? You just follow the slide prompting. Again? Did you say equal? Total, yes. Equals always kept to the end. So total would be, there we go. The total final momentum on the x without 1 and 2, just PFX, is this guy plus this guy. And the total final momentum on the y is this guy plus this guy, which would still be what? Yeah, when you add up, when you plus a negative, negative wins. There we go. Okay, now all the ingredients have been figured out. Now we just have to what? To employ the principle or the law of what? Conservation of. What's the name of this part of the unit? Conservation of momentum. Okay? Conservation of momentum. However, how many dimensions is this problem? One dimension or two dimensions? One or two dimensions, this problem. So, by the way, you might say, well, can't it be a mix because it started with 1D and it ended up being what? It doesn't matter. If at any point it develops a 2D, the whole time we consider it to be what? 2D. If it at one instant it developed a 2D, then you know what? The whole time it's been 2D. We can just say, oh, but most of the time one dimension was kept to 0. But the whole time we consider it to be 2D. Okay. Now we have to what? We have to make them. Yes. Now we have to actually what? Do the momentum conservation or equaling both of them. All right. So let's go to the last slide of this problem. Okay. X momentum conservation. Okay, some people are still copying. Go. X momentum conservation. What was the total X momentum from the 1D state, from the initial case? What was the total 1D from the initial instance? It was going to start with the X. How much was it? Positive 0.32. How much is the total here on the X? Whatever that is. How much was the total on the Y initially? 0. How much is the total Y finally? This guy. So now we're going to start what? Making the equation. All right? Here's my first equation. P initial is equal to what? But on the x's. Again, you have to do each dimension on its own. All right? Pix was the positive 0.32, and Pfx was this. Oh, sorry. There we go. Can someone tell me how to, by the way, can you solve this equation? Can you fully solve it? How many people say no? Ahmed, why not? Why can you never solve this equation? Because you have how many unknowns? You can never solve a single equation in 2 unknowns. The best you can do is what? Rearrange, clean up, simplify, but you can never solve fully. So how can we simplify this to look nice? How would you make it look as easy as possible? What do you do with it? Exactly. So first of all, we clean up the basic numbers. So I guess we're going to move this one here, subtract it. Get some number, and then do what? So again, divide both sides by, okay, hold on. Did you say divide cosine? But the thing is, I have 2 unknowns here, and they have to be kept together the whole time. So I just need to clean up. What's the only thing I need to do to clean the 0.17? Exactly. There we go. Everyone, that is your first equation. V2F cosine theta equals 1.1553. Okay? Can I do the exact same idea to the Y momentum? 100%. It's actually got to be 1 step less because I have a 0 on one of the sides. Remember, this is my solution. You want to skip steps? Feel free to do so. But I'm just making sure that you know where each step followed from. Okay, Y momentum conservation. Pi on the Y is equal to Pf on the Y. What's the good news about Pi on the Y? It used to be what? 0. Nice. How would you clean this up? Which one would you move to the other side? Remember, you want to make it look like this somehow. Yeah. I would definitely, most surely move this term here to become positive and to go to the left side, which is natural for a bunch of variables. Done. How many equations do we have now? 2. In how many unknowns? Also 2. Can you use elimination? Why can you not use elimination when the equations look like this? The equations look like this. Why can you not use elimination? Josh? Exactly. It's not a plus minus. Elimination only works if it's what? If it's not a multiplication system, if it's an addition subtraction system. So we can't use elimination. What can we use? We can use substitution. But whenever you have cosines and sines, you can use trig elimination. Who knows what I'm talking about? Who knows what I'm talking about when I say trig elimination? It is not the regular elimination of grade 10 and 11. I like to call it trig elimination. If you have the parents to be the sine and cosine, what's the name of the child? Sine and cosine always give you what? Tan. Exactly. So what you can do is, again, this is one way of doing it. The other way is to use substitution. I'm going to show you both ways. My favorite way is to do this. I know for a fact that when you divide a sine by a cosine, 2 things are going to happen here. We're going to create a single tan. Also, what's going to happen to these V2Fs? they're going to cancel out. Okay? They're going to cancel out. So, by the way, could you have divided the cosine by the sine? Could you? I'm just saying, could you? Why shouldn't you? Have you ever seen a calculator with the cotan button on it? Have you ever seen a calculator with secant, cosecant, or cotangent buttons on it? No. What are the three main buttons on any scientific calculator? Sine, cosine, and what? Tan. So you always want to create a tan, not a cotan. Honestly, that's the only reason. So what's going to happen here? Cancel, cancel. This thing here becomes a tan, and whatever this number is. All right. What can I do now? Pretty much done. I still did not figure out the angle. I'm almost there. Yes. So yeah, I always choose to divide the sine equation by the cosine equation. Why? Two birds with one stone. The V2Fs go away, and the cosine and sines generate a tan. That's all. What should I do now? Yes, Josh? Tan inverse. So basically do the reverse function of the tan to get the angle. There we go. The second ball needs to deflect at an angle of 46.32, as we said, down below the horizontal. Okay, but that only tells me where it goes. It doesn't tell me how fast it goes immediately after the collision. How would I figure that out? Ahmed? I have two things to substitute in, either the cosine or the sine. Which one? Doesn't really matter. They're both the same amount of work and the same error accuracy. So you know what? Randomly, let's see which one I picked. I guess I picked the sine one. Who cares? You can do both just to check. So what we do here is what is V2F equal 1.21 divided by the sine of the angle we just found, and you get 1.67 meters per second. How would you put that all in a vector statement? Because technically you're being asked for. By the way, everyone, just so you know, if I asked you on a question, what is the speed and angle? Technically, you're done here. But if I asked you for velocity, what do you need to do with that statement? You need to what? You need to combine it together. How would you combine this together? As a vector statement. Anyone? As a vector statement. Remember when we did vectors in kinematics? That's all. Ammar. Of? Oh, hold on. You're doing it Mr. Shiver's way. Just the easy way we did it with the east, south, northwest. Square brackets. What would you put in the square brackets? That's all. Hold on. North. It deflected down. Remember? The other one. South. Okay. Now here's the thing. Depending on which angle you showed me on the diagram, everyone, I don't really care if you show me this angle on the diagram. If you show me this angle, then you're telling me you're going which way first? East, and then you're bending south. But if you chose this angle, you're going which way first? South, and then you're deflecting, which means this sine and cosine would have to be what? Would have to be switched, and you will have to do that anyway when you derive your equation. Okay? That's it. That is our final statement. Obviously, the sig fig situation is, well, I forgot to change it. What's the sig fig situation for the whole thing? 0.16 is 2, 2, all of them are 2. So what would this be? 1.7. And how many? 46. That's it. Okay? Sorry, my bad. I'll go back. Sorry. Now, what was the other? Can someone tell me what was the other method if you did not want to solve it this way? If you did not want to solve it this way, how would you use substitution between these two? I believe Miss Michaela did when she took up a force problem when she was here on the last couple of days. How would you use substitution between these two? Come on. Come on, people. This is not even grade 12. This is grade 11 legit. How would you use substitution between these two? Okay, Kenda, go ahead. Would you? Yes, exactly. You would have to either rearrange this equation or this equation. So let's rearrange this one. So what does this become? V2F equals what? 1.1553 divided by what? Cosine theta, right? Where does this go? In the second equation, in right here. Well, what a surprise. You get V2F sine theta over what? You're creating what no matter what? You are creating the tan. The substitution will lead to a tan. The substitution will lead to a tan. I am just basically showing you the shortcut way of doing it. Okay? That's all. Could you have substituted another way? Yeah, you could have substituted cosine equals what? 1.153 divided by what? But the problem is you don't have a cosine theta here to what to implant. So you always should what? Should V2F replace, which means you're always going to create the 10. Okay? And this is how we do what? 2D problems in the conservation of momentum. Okay? Now, let me start you off with the second problem, because I just want to leave it as practice, probably for the next 10 minutes, and then we're done for the day. Okay, so let's go to the second slide, everyone. Okay. Two balls of what are you given the mass? No, you're not. Yet it's needed for the calculation. What do you remember me telling you about a variable that is needed for the calculation, yet you're not given the value for it? You have one of two choices. Actually, one of three choices. Ammar, give me one choice or one conclusion you know for sure. You can proceed using the variable because you know once the math gets serious, what's going to happen to all the m's? They're going to cancel out. That's one choice. What's another choice? What's another choice if you're not really easy on the believing that it's going to cancel? Which, okay, but then what? To cancel out eventually. But what if you don't want to do that? What if you want to put a number? You have two choices. Obviously, any what? Any number would work. And that's why, what number should we use? 1, which is exactly the same effect of what if canceling is going to happen. Make sense? If, again, if the value is there but not given to you, just put it as 1, which is exactly like making sure it cancels out. Okay, so they have equal mass undergo a collision. Oh, see figure 6. Okay, so, is this a 1D or a 2D? Definitely 2, because that means they're going to deflect for sure, because their center of mass are not lined up. Okay, ball 1 is initially traveling horizontally with a speed of 10. It's coming in at 10. Ball 2 is staying still, waiting for the collision. After the collision, ball 1, the green one, moves away with velocity of 4.7, which makes sense. It lost so much speed at an angle of 60 degrees from its original path, and ball 2 moves away at an unknown angle. Apparently, that's how they move. Ball 1 deflects down, ball 2 deflects up. The question is still the same. How do you what? How do you? So you have 60 there, you have 4.7, and you have. Does anyone know what this symbol is? It's again, theta is for angles, but they have also this common one for angles as well. It's another Greek letter. Does anyone know how to pronounce it? It's basically like a zero symbol, like an oval with a line through it. Anyone knows what it is? It's got to be very common in first year. A lot in both calculus and physics. Anyone knows it? Phi. P-H-I. P-H-I. Phi. In Greek, it's actually called phi. But when you anglicize the word, it becomes phi. So get used to theta and phi, the most two famous symbol for angles, theta and phi. So they used, by the way, did they even need to call this theta? They already have a what for it? They already have a value. So you are more than welcome to change your diagram right now to scratch this theta, keep it at 60, and call this one theta if you don't want to learn another Greek symbol. It's completely up to you. Okay? All right, so let's actually do the whole thing in one slide as a diagram. Okay, let's go. Before, let's sketch the two objects. Which one was lower, green or red? Green. or like the first one. Okay, so everyone, here it is. 1, here it is. 2. This is mass, and this is mass. I don't know what they are. The speed of this one was 10. The speed of this one was 0. All right, yep. And obviously, which direction is positive? Left or right? Come on, right. Okay, let's write the things down. What is P1 on the X? By the way, why do you think I'm not calling it initial? Because I'm already under which instant? I am in the before instance, so that means everything is initial. So let's not bother saying I. We know we're in the I right now. What is this? It's M times what? Is it negative 10 or positive 10? Positive 10. Again, you can just make it 10. I'll just make it positive 10 for today. So 10M. Okay. What's the P2X? Come on. 0. Just put 0. Everyone, if something is not moving, just put 0. I don't need to see a calculation. Okay. P1Y. What's the momentum of the first ball on the Y? Did it have any motion vertically? 0. How about P2 on the Y? Also 0. All right. This was a nice layout. Okay. Let's do the next one. I need a grid. We're going to make this obviously positive. We're going to make this positive, and we're going to make this negative. Okay, which ball deflected up? Ball number 1 or ball number 2? Ball number 2. Okay, that's fine. Ball number 2. Is it the one that we don't know the angle for? Perfect. So everyone, ball number 2 is going to deflect somewhere in this quadrant. I don't know the angle, and I don't know the speed. Great. How about the ball number 1? It deflected downward apparently at what degree? 60. 60 would be somewhere here. Who cares? Just call this 60. This is ball number 1. At what speed? 4.7. Okay, let's show the dashed line of breakdown decomposition. All right, P1X would be mass times 4.7 times what? Cosine or sine of 60? Come on. I want this part. And the good news is I'm using both horizontal angles. So both of these will be cosines, everyone. Both of these will be cosines, and both of these will be what? Will be sines. So cosine of 60. Let's just write cosine of 60. By the way, cosine of 60 is 1/2, but let's just leave it for cosine 60 now. Okay. How about P2 on the X? Come on. P2 on the X. What do you still start with? Always start with what? Mass. Okay. Mass. What's the speed? Unknown, V2F. And is it sine of theta or cosine of theta? Cosine of theta. Good, good. All right. How about P1 on the Y? P1 on the Y. First of all, is it positive or negative? Did the ball 1 deflect up or down? It deflected down. And according to us, we said down is negative. Good. So negative M. Sorry. M. Sorry, say that again. Oh, you mean in the bracket? Completely up to you. You're right. Ammar is basically saying The negative really is not what is not a reflection on mass. It's a reflection on what velocity or direction. Completely up to you. You want to put it in the bracket and then in the math step reflected back here. Up to you. 100%. As long as the minus is somewhere, everything is good. So pen 4.7 sine of 60, and then p 2y is equal to what? Positive, if you want, mass v2f sine of theta. It's basically this guy, just sine. How are we going to combine all of this? Come on. First of all, what am I going to do with these two? What am I going to do with the x's? Add them up. What am I going to do with the y's? Add them up. What am I going to do with the x's? What I'm going to do with the y's? Add them up. And then equate the x universe to the x universe from here, y universe to the y universe. Okay? Let's go to the second slide. Who's still copying? Good? All right. Last slide. Okay. P I x equals P f x. Okay. What was the P I x? P I x was 10m plus 0 must equal what? This guy plus this guy. All right. 10m plus 0 equals m pardon, m 4.7 cosine of 60 plus m v. By the way, there's no need for a bracket here. You can just put m. Yes, m v2f cosine of theta. What cancels out in all of them? All of them have mass, mass, mass. What's your response to someone saying this one doesn't have mass in it? What's your response to them? It's a what? It's a 0. Even if you put 0 times mass, it's still a what? 0 can have anything multiplied by it with absolutely no effect. So, mass, mass, mass. That's the same effect as making it just 1. Same thing. So, 10 equals, oops, sorry, 10 equals 4.7 times cosine of 60 is 4.7 times half, which is, what's half 4.7? 2.35. So 2.35 plus v2f cosine of theta. How can I simplify this? I'm just going to make the 2.35 come this way. What's 10 minus 2.345? 7.65. So 7.65 equals v2f cosine of theta. And that's my first equation. What's my second equation? Same thing. PIY equals P final Y. What's the good news about this? 0. Look, just to confirm. 0 plus 0 equals pretty much the same thing here with two differences. This becomes a sine. This becomes a sine. This stays as positive. This becomes what? Good, good, good. Nice. Minus m 4.7 sine of 60 plus m v2f sine of theta. What cancels yet again? Mass. Even though there's no mass here, there is absorbed into the 0. Oh. Sorry. Cancel, cancel. So we get 0 equals, I need someone to multiply sine 60, which is the 0.8660. So I need to multiply sine 60 in degrees by 4.7. What do you get? 3 point something, or maybe even 4 point something? What's the sine of 60 times 4.7? Come on. 4.07. We'll take that. So negative 4.07 plus just v2f sine of theta, which means I'm going to move the 407 to the negative 407 to the other side. equals V2F sine of. And that's my second equation. They perfectly line up. Done. What do you do now? You divide the sine one by the cosine one. So I'm actually going to remove this line. Yes. Let's make it shorter. All right. So divide this by that. So 4.07 divided by 7.65 must equal V2F sine theta over V2F cosine theta. That leads to theta equals tan inverse of this fraction, 407 divided by 7.65. Who's got this for me? I know one thing about this tangent. It's going to give you less than 45 degrees. If the tangent is bigger than 1, it's more than 45. If the tangent is less than 1, like a decimal, it's less than 45 degrees. What do we have here? 28.01. So I guess we have two sig figs for the whole thing. So it's 28 degrees. Thank you. 28 degrees. And V2F, I don't really know, care, this one or this one. We used sine before. Let's just use cosine now for change of scenery. So V2F equals 7.65, all dividing cosine of 28 degrees. Something in meters per second. Go. 8 point something. Yeah, 8 point something. 8.7. Done. That's it. Welcome to 2D conservation of momentum. By the way, just so you know, everyone, before I finish, we're done for today. But just everyone, listen up. Were those two examples we did today almost identical to each other? What was the only difference in the second example compared to the first one? The only thing that you were not given was what? Was what? But you still had to solve for how many things? What? The what? And? Do I always have to ask you for nothing but the angle and angle and speed of the second ball? I could give you what? I could give you, for example, the angle at which both what? Both balls deflected, and ask you for the what? Ask you for the speeds. Do you see what I mean? You always have to find out how many things? How many things? Two things. They could be what? Angle and speed of one ball, or both, or the two angles, or the two what? Or maybe the mass. Do you see what I mean? I can structure the problem in any way to always ask you for how many things? For how many things? Two things. Or obviously one thing, but sometimes two things. Okay? When we do university problems tomorrow, you're going to see how that happens.